Hello, and thank you very much for watching this presentation. My name is Joan Pau Sanchez. I'm a lecturer in space engineering at Cranfield University, and I will present Comet Interceptor, an ESA mission to a dynamically new solar system object. Before I start, I would like to acknowledge Geraint Jones and Colin Snodgrass, who are the mission PIs, as well as Cecilia Tubiana, who is the science operations coordinator, and the rest of the Comet Interceptor team, which is composed of a large group of scientists and large group of international scientists and engineers. So Comet Interceptor was recently selected as the first ESA F-class mission. F-class stands for fast track, and it comes to join the rest of the missions, the mission classes from ESA, such as the L-class, M-class, and S-class, which are the large, medium, and small classes, respectively. But the F-class is somewhat different because it's not just limited or constrained by the mission cap, by the cost cap, but also by the fact that it's trying to benefit from shared launch opportunities. In particular, Comet Interceptor is going to be launched with ARIEL exoplanet telescope, which will be deployed in the Sun-Earth L2 point in 2028, and therefore Comet Interceptor is going to be deployed in the same place as well. The boundary conditions of the F-class define a modest mission, a relatively modest mission with a cost cap of 150 million euros. Comet Interceptor is a mission targeting a yet-to-be-discovered long-period comet, preferably a dynamically new comet. A dynamically new comet is a comet that is arriving to the inner solar system for the first time. Insofar, we have visited 8 different comets, and the spacecraft that visited those comets returned to Earth images of surfaces that have been substantially altered, both compositional and morphological. These alterations have occurred over the many cycles of activities that these comets have suffered when they have passed through the inner solar system. That's the reason why Comet Interceptor wants to visit a DNC, which stands for Dynamically New Comet, which is basically a pristine comet, with surface ices as first laid down at the solar system formation. Now, how do we do that? Well, so first of all, we need to discover these objects while they are coming in, while they are in their inbound trajectory. All sky surveys nowadays, all sky surveys such as Pan-STARRS and ATLAS are discovering these objects somewhere between the orbits of Jupiter and Saturn, which gives us about between 1 to 3 years of warning time. However, the new survey, which will be soon operational, Beta Robin Observatory's Legacy Survey of Space and Time, also known as LSST, will be actually doing a much deeper survey of the sky, of the southern hemisphere sky. And so it's very likely that we will be able to actually discover these objects much deeper or much deeper into the outer solar system, giving us warning times between 3 to 5 years. Now, 3 to 5 years is still not enough to it's not enough time to design, build, and launch a spacecraft. And so the F-class mission is a great opportunity for a spacecraft to be deployed into an orbit from which it can easily depart the gravity well of the Earth and then reach one of these objects whenever these have been discovered. So Comet Interceptor will be deployed into a large amplitude halo orbit in the L2 point, the Sun-Earth L2 point, as you can see in this figure, this drawing, and it will wait there for a few years, possibly 2 to 3 years, until a ground-based telescope discovers one of these comets, which has an intersection point which can be reached with the delta P capabilities of the spacecraft. At that point, then the spacecraft will depart the halo orbit and will navigate until the crossing point, which will be in which it will meet the long period comet crossing also the ecliptic plane, and it will take the pictures of this pristine new comet. So about nearly 3,000 long period comets have been discovered so far, and 300 of those were discovered in the 10 last years, and the last 10 years alone. Among all of these 300 comets, about 21 of these comets had intersection points with the ecliptic plane that could have been reached by Comet Interceptor, given the delta P budget that Comet Interceptor is assumed to have, is expected to have. This figure here shows the ecliptic plane in a synodic reference frame, so a reference frame that is rotating with the Earth. And then it shows the region that we can access with the spacecraft. And the color map represents the costs in terms of delta V that to access different regions. So you can see the blues represents less than 1 kilometer per second. And the crosses are some of these 3,000 comets which have intersection points near the orbit of the Earth. After some preliminary mission design, what is clear is that Comet Interceptor needs to be designed to encounter comets on a wide range of possible trajectories and encounter speeds. In fact, it can happen that it needs to encounter a retrograde comet, which will mean that the flyby speeds will be in the order of 70 kilometers per second. Also, the total mission duration is constrained to 6 years according to the mission requirements. And so with all of these, then we could run some Monte Carlo simulations to understand the probability of having a successful mission. These, the Monte Carlo simulation, the results of the Monte Carlo simulation are summarized in this picture here on the right, which basically shows that as we are launched in 2028, there is some probability of already having discovered a viable LPC that we can access with a relatively short time of flight. And as the mission duration increases up to 6 years, then the completion probability increases as well to somewhere in the order of 95 to 99% for delta V performances on the order of 1 to 1.5 kilometer per second. Note that here I refer to delta V performance rather than delta V capability of the spacecraft, because the propulsive capability of the Comet Interceptor is on the order of 700 meters per second. However, remember that we are departing from a large amplitudinal orbit, which means that by basically exploiting the natural instability of these orbits, we can gain some excess velocity when we depart the gravity well of the Earth. And this effect, plus then the propulsion capability of the Comet Interceptor, allows us to have a delta V performance for this Monte Carlo in the order of 1 to 1.5. Nevertheless, in the unlikely event that we don't get a good LPC to access, a suitable LPC to access, the science team has identified a list of backup short-period comets with scientific interest that Comet Interceptor could also intercept as a backup options. So in terms of the system, the space segment, the Comet Interceptor will have 3 different spacecraft, which is very useful because then we can have separated time and space variations in the coma. So science of the time and space variations in the coma, as well as enable simultaneous coma nucleus and magnetic field studies at different distances. But it's also very useful because then we can have a mothercraft, a larger spacecraft, which takes a safer flyby path at a safe distance in the order of 1,000 kilometers. And this mothercraft carries also the communication, or will act as a communication relay for the 2 smaller spacecraft that you can see here in the picture. So the spacecraft A is the mothercraft, which is provided by ESA. The spacecraft B1 is also provided, B2 is this one, provided by ESA as well. And then a spacecraft B1, which is this one, is provided by JAXA. This slide presents the scientific instruments that Comet Interceptor will carry. However, since I'm running out of time, I would encourage the viewer to go to the paper. A few words on the mission progress. So phase 0 was concluded. So it was selected. The mission was selected in June 2019. Phase 0 was concluded at the end of 2019. It was officially advanced. The mission was officially advanced from phase 0 to A on February 2020. Soon after, the invitation to tender from industry was released, and sometime in October, then the primes for the phase A should be announced. So with this, I conclude my presentation, and I'll thank you very much.